This is example 12.1 from Discovering Design with Chemistry. The first question says, what are the oxidation states for the atoms in Al2O3? Well, because aluminum is a metal and oxygen is a nonmetal, this is an ionic compound. So we can just look at their charges as ions. And even without looking at the table, you can see that this 2 and this 3 could switch places to go back to where they were before they were combined. You can also look and find aluminum and oxygen and find them that way, like we did when we were making ionic compounds. So the charge for aluminum, the oxidation state is 3+, and the oxidation state for oxygen is O2. So aluminum 3+, and then oxygen is 2-. All right, so the second one asks, what are the oxidation states for the atoms in CF4? Well, CF4 means that we're working with a covalent compound now, so we have to start dealing with other ways of doing this. We can't look at their charges necessarily. So we're going to draw the Lewis structure. If you are not wild about Lewis structures, don't worry. We're about to learn some rules pretty soon in the book so that we don't have to do that. So let's start with carbon and fluorine. So carbon is in group 4, so its Lewis structure is going to look like this. And then fluorine is in group 7, so it's going to look like this. And I know you put on one at a time, but I knew that I was only going to have one side that was short, so I went ahead and just drew them as I went around. And we have 4 of those, so we can keep drawing them. All right, so with this one, it's probably easy to see how we're going to connect them. We're going to put carbon in the middle because it has the most unpaired electrons, and then we're going to put the fluorine on each side, and that would give us the one that fluorine has missing would be where that carbon one fills it in, and that's going to happen on all the sides. So once we've drawn the Lewis structures of this compound, then we're going to look at electronegativity to see what's being pulled. And again, if you're not like wild about Lewis structures, it's okay. We're not going to do it this way the whole time. All right, so let me erase my extras here so they don't get in the way or confuse us. All right, so now that I have my Lewis structure drawn, I can look at it and excuse me, and we can decide which one is the most electronegative, which one's going to pull those electrons to it. Well, because the electronegativity increases as we move up and across to the right on this periodic table, fluorine is going to be the most negative, so it's going to pull those electrons. So it's like this becomes all fluorine and this becomes all fluorine, and the carbon just ends up short 4 electrons, and so the carbon ends up with a 4+ charge because it ends up short electrons, and the fluorine, each of those individually will end up with a minus charge, and there are 4 of them, so their charges get spread out. So the oxidation state of carbon, no, it's really messy, sorry, is 4+, and then the oxidation state of fluorine is 1-. And anyway, so their oxidation states kind of go along with how they're dragged. All right, in the next section, we're going to have some rules introduced, and then we'll make this process a little bit quicker.